Good afternoon, Nigel. How are you today?
I'm very well, thank you. How is yourself, Paul?
Very good indeed. And what a beautiful start to the spring. I just hope it continues.
Yeah, absolutely. I've taken the time out to go and have a look at the allotment this morning, and everything's starting to grow, including the weeds.
That's the problem, isn't it? You can't have one without the other,
Yeah.
unfortunately. But the daffodils have been sort of popping up, and over the weekend they started to blossom considerably, didn't they? But it's
Yes,
always nice.
interesting. I originate from Suffolk. I went down to see my mother because it was Mother's Day, and a lot of the daffodils are finished down there, but here they're only just coming out. So it
Wow.
just proves that there is a north-south divide.
There is, yeah. And we were just joking offline about the time zone, wasn't we?
Yeah,
About the north time, the north south divide, and about the
yeah.
time zones. Personal joke amongst ourselves. So, Nigel, we've been talking via LinkedIn and we've had some in depth conversations about your product. And I'm very excited about your product because I think we're getting to that stage now where people are transitioning away from gas and they're looking for alternatives. And one of the alternatives is to recover that heat to maximize heat replacement from possibly gas going forward. But it also can act as a technology to supplement heating as well, can't it? So
Yes.
thank you for joining us today. And just for the benefit of the audience today, could you please give some background to yourself and your origin story? Because I think the origin story really says it all for people, where you've come from and what really drives your passion for this technology.
Yeah, absolutely. I spent up until recently all of my career in the food industry, frozen, fresh meat, fish, vegetables, you name it. Been there and got the t-shirt. And that sort of, I suppose you'd say, culminated in starting my own cooked meat business in 2006, I think it was. And that particular factory had all the fridge plant in the roof space, which is not really a good plan. And of course, in the summer, it got really hot up there, and I was just pulling my hair out because the fridge plant wouldn't operate correctly in such heat. So I had a lot of compressors tripping out, and I was thinking, how can I get the heat out of this roof space without just putting a big fan in and blowing it all outside? So I started to ask a few questions of people that might know the answer, and I came across this idea of heat recovery from refrigeration. Um, Shortly after that, I exited that business, and I spent a year looking into the feasibility of heat recovery as a business and as a career option, if you like. Um, I did set up a business and I brought in a couple of business partners, but it was obvious that the market wasn't really ready for heat recovery from refrigeration on a scale that would pay three wages and make a profit and all the rest of it.
Hmm.
One of the business partners had a portfolio of small businesses, so he carried on. The other guy was sort of semi-retired, and he was happy to carry on, and I had to go and get myself a job. So I went back into the poultry industry and ran a small poultry processor for 10 years. And in that time, my interest in environmental issues, net zero, etc., grew quite substantially. We invested in a lot of different technologies in that poultry business. There was biomass, including one burner that was using the straw off the farm that produced the wheat to feed the chickens.
Wow.
And then the muck went on the field to grow the wheat. And so perfect circular economy
Wow.
touch. We put in a battery store, solar panels, wind turbines, you name it, everything that you could fit around a farming and food enterprise was represented. Since I've left, I understand they've put in a big solar panel array, 850,000 quid's worth,
Wow.
to complement the battery store that we had and obviously to feed the factory its electricity source. Included in that array of green technology, you won't be surprised to learn, as a a director and owner of a heat recovery business, we put in some heat recovery. And it worked very well indeed. It was 144 kilowatts of heat recovery every hour. So had a very good payback and a very good reduction in carbon emissions.
And what
Uh,
you recovering the heat from?
so it's recovered from a refrigeration system. So for the people who don't know about refrigeration systems, if you imagine your domestic fridge, on the back is a little motor that hums away and gets a bit hot sometimes. So that's the compressor, and that is compressing the gas, the refrigerant gas. That then goes to the evaporator, which on a domestic fridge you'll know as the inside of the fridge, really.
Hmm.
The bit on the back where it's cold is where that evaporation happens. And when compressed refrigerant gas expands, it absorbs heat. So that's basically how it works. The gas is compressed. It goes through an expansion valve in the evaporator. It expands and it absorbs heat. So the it's a completely circular system. So the pressure from behind is pushing that gas through, and it goes to what they call the condenser, which is the grill on the back where the heat comes off.
Right.
So that's any refrigeration system is exactly the same. Compressor, evaporator, condenser. So the heat that comes off the back of there is, in your kitchen, just helps warm your kitchen up. In an industrial commercial setting, it helps warm the planet up by blowing it out through a vent somewhere. Everybody has seen systems on the outside of buildings where there's a fan and that fan is just blowing out heat.
Yeah.
Unless, of course, it's a heat pump, which is sucking heat in. But in the case of refrigeration, if you obviously that heat is a valuable resource. It is energy, and it is energy that is born of the gas expanding and taking the heat out of the room or the fridge that the evaporator was in, and it's born of the electrical energy put into the compressor motor to make it all work. Um, and our rule of thumb is that for every 1 kilowatt of engine motor energy used, you get 5 kilowatts of energy out. So four in the form of heat, one in the form of the heat energy from the compressor. And the way that we capture that heat is, in effect, the compressor is compressing the gas and it's sending it to the condenser. You blow air across it, cools the gas down, and it completes the circuit. So rather than blow the air, cool the gas with air blown across it by the fans, you intercept the hot gas pipe and fit in it a heat exchanger.
Right.
And that heat exchanger, in the case of our system, sits inside a tank of water. The heat exchanger is looped and curled around on itself to give it a nice tight configuration, and the external surface of the heat exchanger, which is made of copper, is milled so that it's got fins on it. And in that way, we can get a much, much higher surface area for the heat to be conducted into the water. So from that, we take our 1 kilowatt of motor energy and our 4 kilowatts of heat energy, gives us 5 kilowatts per kilowatt of cooling capacity. And 5 kilowatts can heat 100 litres of water from 10 to 55 in an hour.
Right.
So that's the energy saving because you're not having to use gas, or in the case of a lot of poultry plants, meat plants. They're in the countryside. There's no gas.
Yeah.
So they're using diesel or LPG, which are even more expensive than
Hmm.
gas, and equally as polluting in terms of
And
CO2
in
emissions.
addition to that, are we making the cooling process more efficient because we're able to heat it down faster or more efficiently?
Yes,
Does that make
yes, there's a
sense?
number of areas where it can win. The direct one is that the fans on the condensers don't have to run.
Right.
So there's an electrical energy saving there of
Yeah.
about 5% of
Yeah.
running the whole system. There's also a few sort of engineering-y, shall we say, knock-on effects. One is it supports if particularly if your condenser plant is getting a bit old, they lose efficiency. I think the figure is 2% per year. So if you've got a 10-year-old condenser, you've lost 20% of your condensing capacity. So if your condenser is beginning to struggle with the heat, then obviously the taking the heat out of the gas before it gets to the condenser
Mm.
means you've supported the condenser. Um, and similarly, that there's that we're really getting into refrigeration engineering here, and I'm not a refrigeration engineer, but you can extend the capacity of the evaporation system as well.
Right.
So you not only get efficient heating in that you're not using any gas or a lot less gas to heat the water, but you're saving and making your refrigeration plant more effective.
Have you ever worked with the specialists, like the walk-in fridge specialist, and talked to him about this technology and the benefits of it? Is there has there been crossovers with these people? Because as far as
Well,
they're
yes,
concerned, they've got the box, they've got the condensing units off the back of them. What you're
really
going to do
the
is,
the market for this heat recovery is, well, it's not, I've mentioned domestic fridges, but it's not domestic fridges because
no,
they are, 120 watts perhaps,
yeah,
and you can't make a heat exchanger small enough
yeah.
or cheap enough to
But
make that
but we
viable.
are talking the walk-in type fridge, aren't we? The
Yes,
larger fridges.
yes.
Um,
So any walk-in fridge, so just even your small high street butcher will have a walk-in fridge,
yeah,
and the cooling capacity on that will be enough to make heat recovery viable. Obviously, the bigger the systems get, then in effect they're more cost effective in that the transport and some of the processes that go to making these systems are the same regardless of how big the unit is. So the bigger they are, then those costs diminish a bit. But they can still be very effective. We regularly quote on systems of less than a year payback, but the average is probably between 2 and 3 years, depending on the requirements of the business. Obviously, the business needs to use hot water to make it work, but they can be used to recover heat for heating, space heating as well. And it doesn't stop at refrigeration systems. Air conditioning is a refrigeration system, and you can tap into air conditioning systems as well. In fact, my favourite project that we've done, it was quite a few years ago. I don't know if you know of, or your listeners know of, um, Potter's leisure facility near Great Yarmouth, or is it
yes, I
Lowestoft? I
know it.
can't
I
remember.
know it very well.
It's where the indoor bowls competition happens, and the toilets next to that the bowling green, the main bowling green, the water to wash your hands is heated from the air conditioning system in the arena
Wow.
um, using heat recovery. So that's, yeah, just a
And
little
what
anecdote
and what
that
temperature did you take it up to then?
we I think that one was going up to 55.
Right.
Because you don't want to make it too hot when it's for that sort of application. Microbiologists and people who worry about Legionella out there will be howling at that number
Yeah, that
55.
I was thinking that
Yeah,
because it's
obviously
more or
we
less
need to be.
60 degrees we need it above,
Well,
don't we?
it's 62 for 2 minutes, I think, or is it five? We tend to advise 65 because then it's not so time critical because at 65 you've got it.
Yeah,
So there's numbers of ways of achieving the Legionella kill. We have what we call a Legionella kill kit, which is an electric heater on a timer with a circulation pump. So at night, when nothing's happening, that will come on and take the water up to 65 before it switches off.
yeah,
That's one option. Another option is to have a closed system where the water, its only outlet goes through a normal gas boiler to take it up to 65. And there's various other options
yeah,
that you can employ. The bigger organizations tend to have their own Legionella policies, but obviously smaller ones don't. And so we give them advice on that
yeah.
level of control.
And you can always use this process as a like a preheat, couldn't you, to top up?
Yes,
So if you
we,
use that as a
we
preheat on the water on the boiler system, probably the you're going to reduce the amount of consumption of that particular boiler anyway, aren't you? Because you preheated
Yes,
the water.
absolutely. We always advise the customer to leave their existing boiler system in place.
Yeah,
One is so that they can achieve 65 if that's what they want to do without a kill kit and the circulation and all the rest of it. And the other one, of course, is if your fridge breaks down, you've got no hot water either.
yeah,
And so you still need a backup for that
yeah.
eventuality.
Or there might be some form of season. There might be there's some places that I'm thinking of. You might have a seasonal or event based type process where you might want to shut down for periods of time, mightn't you?
Yes,
Football
and
clubs, for
indeed,
instance.
most of the systems that we design them to, if you like, with a median between summer and winter.
Yeah,
Obviously, in the winter, the fridge kit isn't coming on quite so often, and in the summer, it's banging away,
yeah.
at full blast.
And
So we
unfortunately,
make
you don't
them.
need the heat then, do you?
But you still might need the heat for
Oh, for hot water.
wash down and
Yeah,
all of that.
yeah,
But you
yeah.
certainly don't need it for the space heating.
Mm,
In the winter, your space heating load is greater, but the fridge plant isn't running so much. So we tend to design the systems with a medium level involved, but obviously that means that in the winter you will still need your sort of gas heating
yeah,
arrangement. Or it could be something else. Our systems can receive um, energy from other systems. So, for example, if you've got solar panels, you can have obviously the option for electric heater to support the system. If you've got a gas boiler, you can do that. Solar thermal systems on your roof, you can use that to support the heat. And even heat pumps. If you've got a heat pump, yes, you're producing some hot water from your heat pump, but that hot water costs money because you're using electricity to produce it, whereas ours doesn't because you're not using electricity to
mm,
produce it. But the two in combination can work very well to be more flexible
yeah.
in various seasonal circumstances.
I think one of the key things here as well is each property will have its own scenario, different systems, different
Yes,
way of doing it, and you as an organisation will take a look at that and then put together the best solution for that.
yes,
Each organisation is different, each system's different, and each outcome is going to be different as well.
yes.
So you as an organisation can be flexible around that.
Yes, we have two approaches. We have what we call our standard range, which we are going to be branding later this year, and if you like, selling as a box set. So it comes with all the bits you need, so that the fridge contractors who sometimes struggle with, well, what do I and how do it all comes already ready done, and all they have to do is plug in the water and plug in the refrigeration, and they're away.
Yeah.
That those particularly suit smaller environments where the requirements are predictable, like butchers, for example, or a small catering butcher. They can go in hairdressing salons. We've even quoted for a mortuary, where the obviously the heat coming off the fridges where the bodies are kept, can heat water so they can clean down after the shift.
Right.
Um, but the bigger systems, we are bespoke designed, if you like. We start the process by saying to the client, what is the cooling capacity of your fridge plant? And they usually don't know, have to speak to their fridge contractor. And when we get the answer back, we can do a quick illustration. We just plug in the cooling capacity, and up on the screen comes an illustration of what can be achieved with that piece of fridge. How big your tank would need to be, what heat exchangers you need, how much that will cost, how much it will save, how much carbon it will save, return on investment calculation, and that can be pinged off within an hour of receiving the information.
Right.
And then if the client finds that interesting, then we'll send a questionnaire or a survey form, which starts to ask some more in-depth questions in order to refine the potential design of the system.
Mm.
We will then refine our quotation or our illustration to turn it into a quotation, which is a lot closer to what the end user is going to need in our experience. But then, if needs be, we will do a site survey. We're currently working. We find that quite onerous because we're a small business and you can't be all over the country all of the
No.
time doing site surveys. But we are engaging energy auditors, and we're training some fridge contractors that we work with regularly. We're training them to be able to gather that data themselves,
Yeah.
to refine the system, to reduce the pressure on poor old us, in terms of gathering the data, because that can be quite onerous because usually the customers don't have it.
Yeah. What's the footprint of the unit that then gets installed?
The smallest unit is 1.4 meters tall, and I suppose footprint it would need about a square meter
Right.
on the floor. The biggest ones, well, it's a case of how big do you want them. The if you like, the standard largest system that we do is 7,000 litres, and that's because that is the biggest unit you can transport on a standard truck. You can have them bigger than that, but then you get into specialist transport.
Yeah.
The tanks, because we manufacture the tanks ourselves, they can, uh, within reason, be any shape or size you want. They can be tall and slim, they can be short and fat, they can be horizontal or vertical. As I say, because we manufacture them ourselves.
Yeah.
Obviously, if somebody wants something like that, the lead time is a bit longer than a standard size tank.
And start to finish, how long's the project? Can once they've placed the order, is it very fast turnaround to get installed?
The standard sizes, which is 120 to 1,000 litres, let's say, in it. So I think it's what 120, 200, 300, 500, 1,000, 750, 1,000. Those can be turned around in 4 or 5 weeks, depending on the pressure that the factory's under at the time, because they have what we call raw tanks already manufactured, and they've just got to complete the process with the various inlets and outlets that are required by the customer.
Yeah.
The bigger units that have to be bespoke built, you're looking at 12, 13 weeks lead time for delivery. If we get in on a project early enough, usually the fridge plant delivery time is of that sort of ilk anyway, so it doesn't
Yeah,
tend to hold up
yeah,
projects. And we prefer to get in on the ground floor because we can influence the fridge installation where it's sited and all the rest of it to our benefit, or to the benefit of the customer. But ultimately, it makes the installation easier if we can have have a say in siting the units.
yeah. And the technology for me sounds quite robust. You seem to have a best practice approach to this. But what's happening for the future? Is there, you constantly got the bonnet up, you're looking at different ways of doing things. If is there advancements on their way? Or have we
Um,
got quite a standstill product that's ready? Obviously it's ready to go now, but are you looking to evolve that long term?
there are developments happening, but as you put it, the technology is so robust and what should we say has been developed over the course of I've had speaking to the factory this morning. They've been going for 47 years.
Right.
So it's not new technology,
No.
it's just a new market that is got interested in it. So the basic technology, the actual heat coil itself, pretty much remains the same. But we're playing with different materials. We can. One of the biggest sales currently is a system that can cope with the pressures and temperatures of CO2
Right.
as a refrigerant. And certainly in Germany, there's a supermarket chain called Edeka that every refurb and new build that they do has one of these systems in. It's a combined heating and cooling system, so that when it's hot in the summer, they can cool the store, and when it's cold in the winter, they can heat it up
Right.
by using heat from the refrigeration. But we also do water coolers, which obviously in itself is a piece of refrigeration to cool the water. But that cooling process then generates heat, which can be used to heat the offices or the hand wash or whatever is required. So, we can do heating and cooling at the same time.
Right. And what do you foresee your challenges going forward as an organization? Obviously, we talked
Um,
about doing many quotes and
yeah.
surveys. That's the biggest challenge you have at currently. But do you see or foresee any future challenges that you need to be aware of?
The biggest challenge we've always had and remains at the moment is the refrigeration installer. Because refrigeration installers, and this is no disrespect to them, but most of them, in the world of cars back in the day when I was a lad, you had mechanics or fitters, and their job is to replace parts. And a motor engineer was somebody who designed parts. And the difference there's that same difference in the fridge world where you've got your guy who does maintenance or installation, just just it's not fair. He's got his set routine for his maintenance, or he's told how to
Yeah.
install the piece of plant. The person that actually gets it is the specifier or the design engineer. So when we speak to a design engineer, they get it straight away, and it's a much easier conversation.
Mm.
But your smaller dad and his lad type of fridge guys, sharp intake of breath, and they put the end user off doing it because they're not comfortable with it.
Yeah.
So that's one of our biggest challenges. We're working on a training module to try to get to those guys to say, look, you don't have to be afraid of this. This is how easy it is. I've been invited to join the Environment Committee of the Institute of Refrigeration
Good.
in their capacity to advise the TICR, which is the government-backed process of looking at refrigeration and its part in net zero, right from production, storage, transport, to try to come up with best practice. So I've been invited to sit on that committee because I've been bleating at the IOR that, there's so many fridge engineers out there who are standing in the way of heat recovery.
Yeah, yeah.
So that's one issue is education, and understanding amongst the guys who've got to fit the stuff or advise their customers on whether they
Mm,
should or not. And then going forward, we hope it's going to be time, our time, because we need to automate the processes of specification.
yeah.
We need to educate other people to specify it. There's no need for us to have a team of 20 people sitting waiting for an inquiry, when all the fridge guys out there could be just dealing with it themselves, direct
Mm,
with their client.
yeah,
So that's the main challenge for us is education.
yeah. And education of the organization, because, do they want that? Can they have that? I know a lot of organizations that have got loads of refrigeration, and not one of them has actually mentioned to me is all that heat at the back. How can we
Mm.
recycle that? And
Well,
it's a bit of a no-brainer as well, but it's
it's a
never,
just a lack of awareness, and
yeah,
that, I suppose, if you like, is my job,
yeah.
because as
Well,
the
and the
marketing.
energy experts. So all the consultants out there listening to this, all the energy experts that are walking around, the amount of air conditioning units I've probably kicked in my lifetime to say, oh, you're not maintaining this, you need to maintain it. But then I'm standing in front of them making a note of what it is, and there's all this heat blowing at me. We
Yeah,
now need to be thinking about, okay, all this heat, we need to recycle that heat.
yeah, absolutely. Yes, you're quite right. I mean, there's a whole industry of energy audit, etc. And that's an area that I've been getting more involved in,
Yeah,
connecting with energy auditors
yeah,
to highlight the fact that this technology does exist. Not many of them realize it. And strangely enough, the most enthusiastic party is the end user.
yeah, yeah,
Whenever I speak to an end user and say, you could recover that heat and heat your water with it, they're, oh, that's a no-brainer. Then they go and speak to their fridge engineer and he goes,
yeah. That's the
oh, I
problem.
don't like that. Seen
Yeah,
that before, didn't work then, won't work now.
yeah.
We hear that all the time.
But you, as an organization, because you're confident in it, do you give guarantees that you're going to make it work? Well,
Yeah, the
you can give them the
guarantees,
case study, can't you?
the guarantees are, what shall I say? Um, the systems are designed around the data that the customer provides us.
Yeah,
And so the system can only be guaranteed based on that data. In terms of physically, the guarantee is rock solid.
yeah,
The heat exchangers themselves never fail because they're a continuous tube. There's no joins or solders or welds to split and leak. And the tank itself is guaranteed by the factory in Germany. The design element, as I say, is guaranteed to produce an amount of heat based on the information that we have gleaned or had to assume. And we state those very clearly in the sale document. The most common issue we have is we're doing installation and the customer comes back and said it's not working. What do you mean it's not working? Is the pipe going into it hot and the pipe coming out of it cooler? Yes. Right, so it's working. Um, when you say working, what do you mean? Well, the water's only at 30 centigrade. Right, okay. Well, we'll come to site and we'll have a look. And every time they're using more hot water than they knew. And so the water is going through the tank so fast, it doesn't heat up to 55.
yeah. It's
It's
not
only
got no
getting to
chance to heat
30.
up.
And that's the most common thing. So
Yeah,
we've started working on establishing the best form of data logger to be able to gather that data well, not automatically, but not relying on somebody's judgment or somebody says, oh, well, I'll get somebody to measure it. And then that person forgets 2 days out of the 5.
Mm.
and so the data is rubbish.
Yeah.
Um, and they're quite pleased to see that the world of electronic data loggers for that sort of application is growing and
Yeah.
cheaper.
Yeah.
When we first looked at this, the system we were looking at was going to be 5,000 quid. And well, if people are looking to buy a £4,000 heat recovery system, they're not going to spend 5,000 quid
No. No.
on a system. We did buy one ourselves to lend to people so that they can get the data, but invariably the cleaner unplugged it, or they forgot to switch it on, or the data is corrupted, and it just
And
became
and.
a thankless exercise.
Yeah. Yeah.
Um, what we have established now, and we're going to be promoting this, is there are actually some very cheap pulse data inline analog systems, uh, uh, data recorders, where you can just measure the flow, and so long as you know that your water's hot enough, you water always starts at 10 to 12 centigrade out of the tap or out of the ground, wherever it's coming from. And if you're achieving your 55 and it's going in at 10, you can calculate how much energy you're gathering.
Right.
So that's a cheap way of being able to assess that. And we're working out how we can make that easy for the end users to do. There's no use, there's no point in us turning up and putting a clamp system on that cleaner's going to switch off. Much better to uh, put it in line, plumb it in, and then nothing can go wrong.
Yeah.
So okay, they're going to need a plumber to cut into the line, but that's not the most onerous task
It's not the end of the
the
world,
world.
is it?
No, absolutely.
So Nigel, we spoke this time last week, and it was then where I realised I needed to get you on here to start educating our listeners and the industry. And I've started with my LinkedIn. I think this is a very valuable, as an ESOS lead assessor going forward. I think this plays a very big part of that in the removal of gas and the approach to net zero of where we're going. And I've been hearing other organisations talking about it, and obviously slightly different in because we know there's other sides of heat recovery that we need to
Mhm.
explore. So one solution don't fit all. We know there's others to be working together, and I know you have been working with another company, another person who, yes, he will be hopefully coming on to this podcast as well, and maybe we get both of you on there at a later date as well, so we can really talk about this technology.
Yeah, well, I spoke to him this morning, actually. He's
All
got a
right,
friend in Ireland that is interested in both technologies. So, we're collaborating on
that's
that.
fantastic to hear that.
Yeah.
Really is.
And buoyed by my conversations with him, we've had this idea of making what we call a spot cooler system, or a kitchen cooler system, which is a small piece of fridge plant mounted on top of a cabinet which has got the heat recovery tank in it.
Right.
And so you can get cool air blown on the poor guys that are sweating away preparing the food, and that keeps them cool. But the heat that it's extracting out of the air to create that cool air can be captured by the heat recovery system, produce hot water for them to clean the kitchen when they're
Yeah.
finished.
Brilliant. I love when I hear the word collaboration developing. It's really, really good, and it's needed. So
Yeah.
Nigel, as I say, I'm really excited about this technology and really appreciate you coming along today. But it's come to that time in the podcast where I'd really like to put you on the spot actually and ask, is there anything that you can give back to our industry today as a takeaway and something for our energy experts to just take away and learn from?
Well, I think we've sort of touched on it. I guess that there's the open mind, where you're actually looking for opportunities. As you said, you can stand next to a piece of fridge plant, you can feel all the hot air coming out.
Yeah,
Well, somebody stood there and feeling all that hot air should be thinking, that's energy. If we can harvest that, we're going to save the planet, um, or some cash, whichever
yeah,
floats your boat most. And the other thing, again, I've touched on it really, is education, is making sure that everybody is aware of this technology. As I said, that our company goes back 47 years, but it started off in the dairy sector, as a lot of these things have. And the heat recovery bit became so successful, they dropped making dairy tanks and just do heat recovery systems. So the dairy industry is quite well tuned into heat recovery, not least because they deal with pasteurization, plate heat exchangers all the time. And we've just got to get that word out that it's just as applicable to any industry, any sector that has air conditioning or refrigeration and needs hot water.
Brilliant. Well, thank you for that. I'd like to put another one in there. We need to get out there and educate
Yeah,
everyone, the end user, the energy experts, the air conditioning and the refrigeration experts out there. We need them all on board. We need to build a collaboration to drive this technology forward because I think it's got, 40 odd years. It's time
it is.
to
It's
start
time.
breathing
Yeah,
and living what we're doing here.
yeah, absolutely. Yeah.
Brilliant. Well, Nigel, thanks again. It has been a privilege hearing this more in detail. I have seen a presentation, which is really worthwhile looking at, and I think it'd be really good if we could look at that further. I'm looking at this. Is that your website, the DK heatrecovery.co.uk? Is that how we
Yes.
can find it?
Yes.
And on there we can obviously find your details and things about information more about the technology as well. Yeah,
Yeah, there's probably too much on the website, to be fair.
right,
But if for anybody who thinks, well, is it for me? Take a look at the case studies. You'll see Wensleydale cheese on there. You'll see berry black pudding. You'll see Marston's Inns. We cover a lot of ground.
right. Nigel, thank you very much again. We look forward to hearing more about this journey as we go forward. You're more than welcome to come back and tell us, what's happening around the corner in the future. But in the meantime, please, you and your family stay safe in these times.
Well, thanks for the invitation. It's been a pleasure.